Hello everyone. In this video I will show you to how to run the regression in Excel. So we have the data right here. It is for the movie industry. So you have 4 variables and the definition of the variable is here. So we have the X1 is the first year box office receipt, X2 production cost, X3 promotion cost, and X4 total book sale. Now the question I want to ask is, which factors influence the first year box office receipt? So people think, okay, total production cost should have some relation with the sales, right? So how can we visualize the relation of the two variables, the sales and production cost? We can use, of course, graph, right? So we should use a scatter chart. So you go to the insert chart section, scatter, and then click right here. Yep. So you can see that on one hand the vertical is the production cost and the horizontal is the receipts ticket sale, right? So you see all the dot here represent the observation we have. For example, that one I don't know, 4 and 54, where it should be here, it should be this observation. I highlighted 33. See, production cost is about 3.5 and the sales is about 30 million. Yep. So each dot here is an observation. So we see that there is a positive relation between production cost and the sales, ticket sale, right? One way to better show the relation is to create a trend line. So click on the chart, highlight all the dot, right click on the dot, you see add trend line, click it. So normally you use a linear right here, hit OK. So you see that there is the trend line is added, and as expected it is upward sloping, show you a positive relation between the two variables. Yep. Now the disadvantage of chart is it cannot quantify the impact. You know, there could be a lot of positive upward sloping line, right? And we cannot like calculate what if we increase the production cost by 10 million, how the sale will change, something like that. So in order to answer those kind of questions, and of course in order to perform a better analysis, we use a regression technique. Let me delete the chart. Okay, just leave it there. Okay, the regression technique is, okay, so you click on data tab. I don't have the regression here, that's good. So let me show you how to get them. Click on file, go to option, go to add-ins. Give me 1 second. Add-ins, and then analysis toolbar. Click go. Select the analysis toolbar. Hit OK. So here you see under the data tab you have the data analysis. So let's click the data analysis. Okay, move all the way to R, regression. Yep, and hit OK. So now, like we discussed in class, the input range Y and input X range, you know, Y range and X range. Y is kind of independent variable. So you have to select your target, and in this case it is the ticket sale. So how the ticket sale is affected by other factors. So the ticket sales stay in the Y range. So you select it, whole thing. Yep. The input range is kind of, loosely speaking, it is kind of the cause or the factor that influence the Y range. And in this case, the factor we are talking about is total production cost. How total production cost in X range affect the received sale in Y range. So here the X range we put total production cost X2, right? And remember, because we select the header of the column, so we should put the labels. Yep. So now we should hit OK. Yep. Here the regression result, quite a lot of number. So for this video, I want you to pay attention to these few things. Okay. The model from this number is, the model from this regression is, we have the Y, right, which is the production cost, equal to, okay, the intercept 1.512. Here, the intercept right here. Okay, 15.51286, right? And then now we have the production cost. The coefficient in here is positive 7.9, so it is positive 7.977934, right? And then multiply by the factor itself, which is here the X2, or the production cost. Yep, it is our model. Now the meaning of this model is X2 and Y has a positive relation, which is shown in the coefficient right here. It is positive, so it is positive relation. It also means that if we increase the X2, Y is supposed to increase by 7.9. In this example, it means if we increase the production cost by say $1, ticket sale should increase by $7.9. Or if we increase the production cost by $1 million, ticket sale could increase on average by 7.97 million, right? Yep. So if we ask, what if production cost increase by 20 million? So in this case, we should expect that the receipt sale increase by 20 million multiplied by this number, right? Equal to, let me increase the font size. So the receipt sales, you can expect it to increase by 20 multiplied by this number, right? And actually it is here. And then hit OK. So you should looking for an increase of about 160 million receipt sale, and again it is an kind of expected number. We don't know for sure, but based on our model, based on our data, it is what we should looking for, should expect. Okay. Now the second thing, equally important, is here the T-statistic. So the T-statistic show you how powerful or how reliable the relation. This number is big, but may not be reliable. And if it is not reliable, you cannot do any forecasting or meaningful analysis, right? So the T-statistic here will show you whether it is reliable. And but it means basically the absolute value of the T-stat should be greater than or equal to 2. Absolute value of the T-stat, and if in this case, because the T-stat is 6.5, it means it's more than 2. So it is significant. Now, in some situation, you see the absolute value of t statistic is, say, like negative 0.5, negative 5.3. Is that significant? Yes, it is significant because the absolute value of 5.3, again, the absolute value of negative 5.3 is 5.3. It is more than 2, and it is significant. Okay. However, if the t statistic is about like a 0.9 or negative 1.8, so in this case they are not significant because the absolute value is less than 2. Okay. People can also look at that one here, the p-value, to assess how significant it is, and normally we looking for the p-value of less than 5% for the relation to be significant. So in this case, you see that t statistic more than 2, p-value and less than 1%, so it is very significant. Yeah, that's all. Thank you.